Okay, all right. So also Graham and the entire EnOcean Alliance team, thank you very much for hosting this interesting webinar. I represent Dracula Technologies, which is a French company, and we are specialized in low light organic PV harvesting, which is the other part of this webinar. And I'd like to show you what the state of the art, state of the industry is in the OPV business. So start off on energy harvesting for those that have not been sort of deeply into this. I mean, I come from 15 years IoT. I did NFC, RFID, and LoRaWAN before I joined Dracula. So I have really an IoT background, and I've run into large IoT projects where the battery got in the way in terms of rolling out and deploying on a large scale. And first of all, there's this process continuity, which is not trivial because the IoT is all about collecting data, and those data is basically used for applications that will drive business processes within the company, right? So if the sensor goes out of battery, you can imagine that's unacceptable. And in order to do that, companies have to organize staff to avoid that batteries will go down, right? And the sensors keep working. So then we're at the second bullet, which is total cost of ownership. I've seen enterprise clients calculating the amount of effort of staff, how much they need to sort of forecast for, say, the next 10 years to go up the ladder, get the sensor off the ceiling and replace the batteries. It's a huge cost, right? It can kill many business cases up front. Thirdly, it's a regulatory compliance, which becomes more and more relevant, as we all know. It's coming down from EU, but also the US, more and more green technology is being required. Even in an ocean ecosystem, you see RFPs coming up that actually require battery-free devices. Last but not least, I think we all have also a sense of sustainability, which is if you think about billions of IoT devices, and if half of those devices, the batteries are being wasted not in a proper way in terms of recycling, it's just unacceptable for having these amounts of batteries just entering up into nature. Graham just mentioned briefly, there's other, I mean, of course, EnOcean was the first, but there's other wireless protocols in the IoT space that are now embracing and adopting energy harvesting into their protocols. So, of course, Bluetooth is also getting into this. We know that a company called Wiliot has RF harvested Bluetooth sensors, which are almost like RFID tags or labels, if you like, that are now making their way into the logistics space. We know that I think the British Royal Mail is using that, and it's kind of a game changer compared to RFID, passive RFID. Then there is other standards like Zigbee that launched Green Power already some years ago. And as Graham mentioned before, Ambient IoT is the credo that 5G or the 3GPP consortium is launching. And there will be in Q3 in the release 19+, there should be an Ambient IoT spec for energy harvested devices, which actually will make those devices much more energy conservative in transmitting data. I mentioned TCO, and I brought a case here that I actually was exposed to with a large IT services company globally. And they actually deployed about 50,000 sensors in about 50 buildings, I think in 15 countries. And I got access to the TCO calculations. And if you look at the total cost of ownership over a 10-year period, which is then the 100%, about 40% was for the hardware, for the IoT sensors. I talk about a LoRaWAN solution here. So there were LoRaWAN gateways and cabling required. There was software required, and there was project management required. So there was about like a bit more than 50% of the total cost of ownership that went into the CapEx, right? The capital expenditure / investment. And of course, sorry, before I forget, the deployment of the entire installation. And the operational expenditure, calculating over 10-year periods, several battery replacements in all those 50 sites for 50,000 sensors is like 25-30% of total cost of ownership, which is a significant part, which is highly underestimated by many enterprises if they go into this IoT kind of solution space. The batteries as such, of course, depending on what batteries, lithium or alkaline or something else, is also a significant portion of the cost. Then there's, of course, the wireless communication cost, connectivity, and there's like 5% for the overall maintenance and support costs. So you can see that the batteries make up for a large part of the total cost of ownership. Now, if you do the benchmark against a organic photovoltaic solution instead of a battery solution, it's going to look like this. We just saw the battery power solution, which is at the left side, and at the right side you can see the OPV-based solution, which has a much lower operational expenditure cost. So the battery solution would cost over 10 years about 6.5 million euros, whereas the organic PV solution costs 4.5 million. So they're actually going to save 2 million euros if they do the organic PV solution. Now, energy harvesting, I don't think I have to tell, but for those who are not familiar, we are in the light business. My previous speaker, of course, we're in the kinetic business. And then you have also other sources of energy harvesting like thermal energy and RF radio frequency. So within the light harvesting technologies, everybody knows the typical solar cells or photovoltaic cells. They're very common since whatever 40, 50 years, used in pocket calculators and now going on the rooftops of buildings. That's completely different from organic photovoltaic, and I will show you in a minute. Before that, I want to sort of share with you some market research that shows how light will be the main source of energy harvesting for IoT low power devices. Secondly, it will be vibration harvesting or kinetic, and then the other sources, right? So that's an interesting, I think, perspective on the future of energy harvesting in this context. And the other one I want to share with you is what application will gain most of energy harvesting. And it's predicted that smart building, home automation will be the main application, before then in a minor part, industrial, transportation, other applications. So organic photovoltaics, the product that we, Dracula Technologies, are manufacturing, is having some very unique features. First of all, it harvests at very ultra low light, right? I talk about, excuse me. I talk about lux levels that can go beyond 100 lux. Now, in a typical office space, everybody knows is around 500 lux. So talk about 5 lux, it's almost like there's no light at all. And that makes a big difference for many applications, because the robustness of a sensor and the performance is sort of guaranteed at almost dark environments, right? And that's a game changer. The other thing is that we do inkjet printing, the way of we manufacture those modules, which gives us complete flexibility in terms of shape, number of cells, the form, the layer, and the coating, right? So you can just pick whatever design you want. We'll manufacture that. Small series, large series. Thirdly, it's all organic materials. We're not use any rare earths. We don't use any toxic materials. The lifespan, of course, has to be very long, because you don't want to swap modules. Actually, have to swap batteries. So we can guarantee 10 years and beyond. We've done age testing, and we get like at T80, 80% still performance after 10 years in indoor environments. And we produce at industrial scale, where I will show you the new factory that we launched last year. So in terms of the design flexibility, I show you a couple of examples that what we can produce and what we have produced for certain customers. So yeah, anything goes, right? Sky is the limit. In terms of shape, in terms of number of cells, how many cells, how they're going to be configured. You see the lower left, which is just an example of something we produced as a gag for some promotion products. And you see in the middle here, different coatings, right? We can do any kind of designs and graphics that fit to your particular sensor design. So the core technology is organic photovoltaic, and we call that layer, which is our trademarked product. And you can see at the right side an animation of how that works in terms of the photons and electrons. And it's based on a 5-stage process, right? Also, the simulation shows those different stages at the right. And it's all about organic materials from carbon, hydrogen. It's being multiple layers that we print on top of each other. Sustainable materials, no rare earth use, and the solvents that we're using are environmentally friendly. So really green technology. For those who have never built an autonomous device, it's not just that you replace a battery with a harvester from Dracula or anybody other's harvester. There's more to it, right? So the way we go with customers is we build a so-called energy brick. The energy brick usually is always inside a sensor that has to communicate wirelessly, whatever protocol you see below here. And you will have to have some storage because there will be situations where actually there will be completely zero light. So in those situations, you want to sort of store the energy and be sort of able to still have the sensor performing and transmitting data even in a complete dark situation. So we're using some of our partners, supercaps or micro batteries, but also we launched a product called Layer Volt, which is a combination of energy harvesting and electrical storage on the flip side of the harvester. And I'll talk more about it later. And at the right side, you see the different power management IC options that we typically work with creating those energy bricks, because the PMIC needs to operate and to actually manage the flow of energy between the PCB and the storage, between the harvester and the storage, between the storage and the PCB. So you really need that PMIC in most of the applications. What kind of applications we've been working with our clients? Of course, smart buildings, be that temperature, humidity, or air quality monitoring, or room sensors. This is a mainstream vertical that we're working on. And that's why we just joined the EnOcean Alliance last year. Secondly, smart asset tracking, very interesting, because you don't want to replace batteries in warehouses and logistical centers. And there's a big demand for trackers or cold chain loggers that can actually operate without batteries and hold data for a long time, be that on a container journey across the world or on a truck journey across Europe. So energy harvesting in combination with storage is the way to go. Then we're serving other verticals. You see here electronic shelf labels, ESL. Think about a store which has like 10,000s of ESL labels that will hold for a year or a little longer and then have to be replaced, which is a huge operation for the store to exchange all these ESL labels. So we work with basically all the main ESL manufacturers to bring products to market that can do a batteryless solution. And of course, remote controls and wearables is other applications that we actually work with clients on. I brought 3 examples of customers that we can talk about in public. So one is CoolR, an American company that created a solution to solve a problem that vending machine operators are facing. So the challenge that they have is if they want to do stock taking, this is very labor intensive, right? So if you can automate that with an AI camera that sits inside the fridge, you can save a lot of travel for people to operate those vending machines. So the solution is to connect that AI camera to a cloud application that transmits data either every hour or every day. And the sensor is powered by organic PV from our company, Dracula, which is harvesting ambient light from the surroundings. And it makes the sensor basically completely autonomous. It's quite a big storage element inside this sensor that also makes sure that it's completely dark. It will still work properly. And they have designed this to work 9 months in a complete dark environment. So this is a very robust way to solve this solution. And also the battery, if it would not work because of cold conditions, there's a way to actually work from the harvester, right? So it's a hybrid solution. Then smart labels. There's a Swiss company called Truvami that has created a smart label that can actually log data on the journey. through logistical operations in warehouses or industrial applications, and can provide geolocation data outside as well as inside. So that's a real game changer. And this is done without batteries, right? So with this label you see here, you can get a location, but even temperature and other condition data wirelessly communicated through a LoRaWAN network that communicates with the cloud application of the client and actually provides full visibility on the assets that are carrying such a smart label. This is actually like, you could say, RFID 2.0, because it just brings real-time location tracking up to a new level, completely passively, completely autonomously. And this is like, as Graham said, this is ambient IoT. In the smart building space, we have a customer called Orioma, a French company that has created ceiling-based presence detection, PIR sensors. And the challenge here, of course, is how can we avoid that people have to climb a ladder to change the batteries, right? That was the main challenge, and that's how they came to us. And this is a LoRaWAN sensor communicating wirelessly. And the smart thing they did here is they created a 360-degree angle, so it's actually catching light from any direction. And since we are as flexible as it has to be to produce such a flexible OPV module, you can see at the lower left that we just produce like half circles that you can fit together as a cone, which goes into those sensors. Now, light is not something that's pretty stable in an environment like an office space. You see here a snapshot of light intensities. So at the window, you will get like 3,400 something lux, but if you look under the desk, you only have like 13 lux. So there's a huge variety in light intensities inside a room, which you would never guess, which actually requires a sensor that, for example, a desk sensor that sits underneath a desk to detect where the people are working at a desk, has to be able to harvest light from only 13 lux, right? That's where we're coming from. It makes solutions very robust because you don't have to worry too much about, will there be enough light, which many customers are asking us, and we show them that this is possible, right? It's a game changer. This is to give you quickly a feel for how much electrical performance you can expect from different modules. The module I show at the right side here is like 6 by 6 centimeters. And if you look at, say, 1,000 lux, the lower row, you see at the most right column, the power max, you get like 1,025 microwatts out of this module, which is about like 1 milliwatt, which for most low power devices is enough to have a proper designed PCB. As I said before, we opened up a new factory in France to deal with all the large demands that we're getting for producing millions of OPV modules, and I'd like to sort of give you the gist. Yeah, so I thought I'd show you this because some of our prospects and customers say, hey, inkjet printing, that sounds like easy, right? So no, this is high tech, this is clean room manufacturing to get to this kind of high performing organic PV modules. And it took us like more than 10 years to get here, right? So we're well funded by several tech companies as well as financial institutions. And we invested at least 10 million euros just in the R&D to get to a product that can be manufactured on large scale, high performing, low cost. And this factory is ready to manufacture at least 150 million square centimeters a year at one shift. And if we go to 3 shifts, we're close to 500 million square centimeters a year that we can manufacture. So we're ready to roll. We have a team of more than 40 people working in Valence, which is the southern part of France. And we got like 29 patents granted or pending. So before I close, I want to show you this latest product that we launched last year. We got a couple of awards, the CES and other big shows for this game-changing innovation, which is, as I said already earlier, it's combining at the front side the energy harvesting module, organic PV, and having a storage, printer storage at the back, at the flip side of this thin film flexible product, right? So it gives basically almost a complete solution, replacement solution for any batteries that go into sensors, and you can shape them in any form. So with that, I'd like to close here and open up for questions. Thank you very much for having attended.